Kai was a small parrotfish who lived in the shimmering coral gardens off the coast of the Florida Keys. Every morning, sunlight streamed through the turquoise water and danced across his home into a maze of coral towers, sea fans, and the anemones that swayed like the living tapestries. The reef was a city, alive with color and sound, shrimp clicking, tanks darting, and turtles gliding overhead. But one summer, something changed. The water didn't feel the same. It was warmer, just a few degrees, but enough that Kai's coral home began to pale. The once vivid pinks and purples turned into ghost white, as if the color was faded and drained from the world. Tiny fish moved away, searching for food elsewhere. The shrimp stopped clicking. Kai didn't understand what was happening. The coral that had sheltered him since birth, his home, his protection, was dying. On the other side, above the water, humans continued their lives. Boats skipping the surface, factories releasing invisible heat into the air, global currents carrying the warmth into the ocean. A change so small it could be barely felt by a human hand was rewriting the entire underwater world. Within months, half the reef was gone. Kai searched for a new coral, but each patch he found was fading too. Without the coral, algae grew unchecked, covering the reef in a suffocating film. The brilliant city of the sea was becoming a wasteland. But this isn't just Kai's story. It's the story of Florida's reefs, one of the most biodiverse ecosystems on Earth, now facing record-breaking heat and bleaching events. Every year, more of these reefs vanish, taking with them thousands of species that depend on them. Our project began with Kai. We asked, what if we could see these changes before it's too late? By using real-time ocean temperature data from the National Oceanic and Atmospheric Administration, our system predicts which coral reefs are most at risk from rising temperatures, so conservationists can act before the next bleaching wave hits. Kai's reefs faded because no one saw the warning signs in time. The ocean had the data, but not the system to translate it into action. That's why we built OceanIQ, an intelligent information system that predicts coral risk zones, turning real-time data into foresight and foresight into hope. So, why this matters now? The Florida Reef Tracts, the only living coral barrier reef in the continental US, once stretched 360 miles. Today, it faces unprecedented threats, putting both nature and coastal communities at risk. Florida's reefs drive 2.7 billions of dollars annually through tourism, fishing, and coastal protection. Reef collapse means lost livelihoods, failing fisheries, and costly storm damage. Record-breaking 2023, hottest ocean temperatures ever recorded in Florida Keys, 101.1 degrees Fahrenheit. Protected but dying. Even with National Marine Sanctuary status, since 1990, reefs are declining 2% annually. So this is our last chance. Next 10 years critical for intervention before ecosystem collapses and becomes irreversible.
Now that we saw about the need for OceanIQ and its urgency, now we are going to see about the features it is taken into consideration. These are the data points that OceanIQ is going to perform over. Now, as you can see, there are pollution level, coral cover, water temperature, and fishing activity, which are the main reasons for coral bleach. So how is OceanIQ unique from its competitors? OceanIQ is unique because it has the specialized focus only for the coral reefs for around Florida region. Proven data built on NOAA's gold standard dataset, actionable AI, not just monitoring predictions. It also has recommendations that is going to be implemented via a chatbot. Accessible interface. OceanIQ's interface is going to be user-friendly, that people do not need math background to understand the analysis in it. Scalable work frame. It is the OceanIQ's web performance can be scaled with inserting data from the other regions of the USA's coastal regions. Shows economic impact. quantifies reef health in relation to tourism, fishery, and local livelihood. Integrated decision support tools. It combines with data visualizations, prediction, and recommendation into one intelligent system. Scenario planning stimulates future outcomes under various climate and conversion strategies. From satellite to solution. Now we will see uh, how OceanIQ is performing. That is the background framework of the OceanIQ. Initially, the data points are collected from the satellite images, that is directly from the NOAA. The data points are then run into a machine learning model called random forest, which will give out the analytics for the predictive insights. The insights will be the insights will be now made use for the actionable recommendations for the future actions.
So
Along
while
along with the data seen now for the future expansion uh, Ocean IQ will also use these data, which will help in uh, increased performance like automated image processing, generate comparative reports for policy briefs, etc. Now we will see a quick demo of the dashboard.
So while this is the demo of our project, our final deliverable, while OceanIQ already provides a predictive insight for coral reef conservation, our vision stands far behind the current prototype. We imagine a smarter, connected, and more participatory ocean intelligence system. And let's explore how evolves from today's AI-driven model into a quantum powered ecosystem for the future. We begin by comparing data from protected areas like the Florida Keys with the unregulated Caribbean offshore zone. So this demo, the table shows temperature and heat stress data collected from NOAA Coral Reef Watch. Each row represents a specific data and geographic site. What we discover is that the protected zones tend to show slightly lower heat accumulation over time, meaning that conservation policies are already reducing thermal stress. This comparative analysis forms the foundation of our predictive models, helping us understand which reefs are most vulnerable and which are recovering. The line chart of SST over time, we can also visualize the sea surface temperature over time. The, in the demo, the blue line shows natural temperature variations, while the dotted trend line indicates an overall warming pattern. By tracking this shift, we can detect when the temperature reach critical thresholds for coral reefs. For instance, a rise above 30 grades can trigger mass blanching events. OceanIQ continuously updates this data, enabling early detection and real-time alerts to conservation teams, turning observation into immediate action. Also, we have an heat map. An heat map. We move from visualization to machine learning. The bar chart displays the most important feature identified by our random forest model. The top predictor are degree heating weeks, hotspot temperature, and month of observation, the key factors influencing coral stress. We have the confusion matrix confirms the model's perfect accuracy. Every high risk event was correctly predicted. The precision illustrates how AI transforms environment monitoring, moving from passive observation to predictive intelligence. And the risk model, we talk about the risk model. The risk model is the heart of OceanIQ. It's the random forest risk model. It uses hundreds of decision trees to classify each zone into low, medium, high bleaching risk. With the interactive sliders, user can fine-tune model parameters such as test size, number of estimators, or tree depth, balancing speed and accuracy for different research needs. The current model achieved a perfect score, one accuracy precision recall, demonstrating the potential for a fully autonomous marine risk prediction system. And now we are looking for a new way to predict, a new way to improve this model. We're looking ahead. OceanIQ will evolve through the integration of quantum computing. Traditional AI models can process around 30 to 50 key variables effectively, but quantum algorithms can handle thousands simultaneously, including ocean chemistry, salinity, biodiversity, and human impact patterns. Through quantum machine learning, we can detect coral stress signals before they appear, simulate ecosystem evolution over decades within seconds, and dynamically optimize marine protected areas as conditions change. The future vision is an intelligence digital twin of the ocean, a living model that learns, adapts, and helps humanity act before damage becomes irreversible. Future vision is also delivery real-time alerts via mobile or email to reef manager whenever temperature or stress anomalies appear, enabling responses within hours instead of weeks. This creates a hybrid data ecosystem, combines satellite, sensor, and drone data for 24 on 7 reef visibility and faster decision. Meanwhile, a quantum decision support system using Cubo will dynamically model and prioritize reef protection, optimizing for both ecological benefit and economic feasibility. And through a gamified public dashboard, citizens around the world will engage directly, exploring reef health, reporting observation, and contributing to oceans EQ growing intelligence through citizen science. To make Ocean IQ more scalable, it integrates multiple global data sources and the visualization tool. So I can say from satellite to data predicted model, but it's not just a data. It's about listening what the ocean is telling us and using technology to respond before silence becomes irreversible. The ocean is speaking through data. The ocean EQ help us listening and understand and act.